All right, what's up, guys? This is Mr. Myesis. I don't know if I screamed right in your ear right here, but I'm hanging out in my classroom right now after school today, and it is raining outside. Yes, the rain has finally come to California. It's we get off and on rain this last time, but man, I really hope our drought ends soon. So we got a little bit of rain. I'm not sure you're going to hear it in the background, but my door is open, so if you do, fun for you. So if you're a Californian, you're watching this video, so at least we're getting some rain, right? So in this video, I'd like to go over computing limits and doing limits of functions using the limit properties. Now, I'm not going to go over the limit properties. So the limit properties are basically what we use to do this. So I'm just kind of circumventing that, and we're just going to do some simple computing and some simplifying. Okay, so these are some basic limit problems. All right, so the first type of example I have is computing limits using simple direct substitution. And that's right, when we have a limit, we can plug in the x right into our function that we're finding the limit of. All right, so this is going to, the limit as x approaches 2 of x squared is going to be 2 squared, which is 4, and that is it. Some of you are going like, really? That's it? Yeah, that's it for now. Okay? And you're like, oh, Mr. Myesis, for now, how is that going to get harder? Well, you get to see. So we're going to plug in, and we're going to get 5 times 2, which is 10, plus 6, square root of 16, which is 4. All right, that's just a coincidence that they're both 4. But that's all you got to do, guys. Plug it in. So we're going to plug it in. So we're going to see if it works. If it gives us a whole number or, a fraction, whatever. If it gives us a number, we're good to go. That's our limit. Well, what happens, Mr. Myers, what happens if it does not give us something that works? Let's see. You should always plug in the number just to check to see if it worked out like the ones that I just did. Okay, so step number 1, plug it in. Well, let's say I plug it into here. Negative 3 squared minus 9 over negative 3 plus 3. Wait a minute. That gives me 0 over 0. What? 0 over 0? God, that's not even undefined. Like if we plugged it in, let's say, let me show you something. Let's say we had the limit as x approaches 1 of 2 over x minus 1. All right? We plug in 1 and we get 2 over 1 minus 1, which is 2 over 0. Well, that's undefined, right? Undefined. Undefined. We can also say the limit does not exist. DNE. The limit does not exist. Okay, if we get 2 over 0, because that's undefined. In fact, if we looked at this, this would probably be approaching infinity or negative infinity. So we're going to say does not exist in this case. Well, over here, 0 over 0 is even worse situation than getting 2 over 0. It's not does not exist. This is actually called an indeterminate form. Indeterminate form. So we can't even determine what it is. So we've got to use something else. So if you see an indeterminate form, it means that we've got to do something else to simplify this limit, this function that we're taking the limit of. So we're going to simplify. For now, that's what we're going to do. We're going to simplify. So we're going to take a look at this, and we're going to say, can I simplify this? Well, I sure can. I can factor the top using a difference of 2 squares. Then my x plus 3 cancels out, or gets reduced. And then now I'm simply doing the limit as x approaches negative 3 of x minus 3. So now I plug that in, and I get negative 6. Which is fine, because even though I have a hole in the graph at negative 3, the hole in the graph does not affect our limit, because remember, a limit is as it approaches, not what it's equal to. So this is our limit. All right, so what do? You simplify by factoring. So if we plugged in 2 here, we're going to get a 0 in the denominator, 0 in the numerator, so 0 over 0. Remember, if it's just a 0 in the denominator, we put does not exist. Here, we're going to go ahead and factor. So x plus 6, x minus 2, all over x minus 2, leaves me with the limit as x approaches 2 of x plus 6. Plug in 2 and I get ocho. All right. We get 8. All right, let's do another one here. So if I plug -1 in here, I'm going to get 0 over 0, which is indeterminate. So now I have to factor. So I get 2x minus 3 times x plus 1 over x plus 1. X plus 1 simplify out. Limit as x approaches -1 of 2x minus 3, which is, let's see, 2 times -1 minus 3. I don't want to mess up my math here. Okay, everybody, I can't take a breath here. -5. There we go. All right, last one here. So we're going to factor x minus 3, x minus 1 on the numerator, x plus 4, and x minus 3 in the denominator. The x minus 3's are gone. It's gone, gone. And we get x minus 1 over x plus 4. Plug it in, and we get 3 minus 1 over 3 plus 4. You don't think I'll have to pay for the rights just singing that jingle, do you? I hope not. 2/7. All right, 2/7. Let me check my math. 3 minus 1 is 2. 3 plus 4, 4, 5, 6, 7, 2 over 7. Yes, that looks right. So that is my limit. There you go, using simplification to do limits. Bye.